to talk about transitions and animations, as Brian mentioned. There's also like a story behind building stuff for production and about mistakes that I've made in my experience as a developer. So I hope that you can see the mistakes that I made and get the learnings and avoid them in your daily job and be more successful building applications for production using React. So a little introduction about myself. My name is Jeremias Menichelli. That's how it's pronounced in Spanish. If you can pronounce it well, like, I don't mind, honestly. Just reach out to me. I'm a front-end engineer in the design system team at Typeform right now. And those are a bunch of useful links where most of the material that I'm going to present today is. So feel free to check out after. So quick summary of what we're going to see today. First of all, we're going to go really quick about like declaring routes in React applications, just as an introduction, in case you're not familiar with it. And then we're going to go through the React Transition Group API, which is what we used in my previous company to do view transitions in React applications. Then we're going to try to combine both to achieve custom transitions in this React application. So what we're expecting is that the application will have a complete different animation on each view. Then we're going to discuss a little bit about kicking off transitions on first load. It's mostly why this talk exists. It was kind of trivial. You might think that it's not that complex, but it is, at least in my experience. And then we're going to go over some conclusions. So let's start, because lunch is right ahead. First, we're going to see routing. We're going to use React Routed Down because it's maybe the most popular options that we have right now on the industry. It comes with a bunch of useful components. Right now, we're going to see browser router, switch component, and route component. So how these three components interact with each other is pretty simple. We're going to see a really oversimplified example. I know this is not probably a real production case, but depending on the project you're running on, it's going to be that different. So basically what we have is our application. We have an app component with the links. And you see that we're wrapping everything in a browser router component. This is going to handle all the logic behind the history changes and the location. And instead of it, we have a switch. What switch is going to do is basically see what is the first route that matches the location and immediately render that view. So for that, right now, we're declaring just 3 views, like a home and an author and an about view. And we pass the path and the component to each view. So if, like, assuming that we have some content on each view and we have slides and everything, animation should look something similar to this. You see that when the user clicks each link, you have a completely different view. You see that the homepage is different from the rest of the routes. So that's it for routing right now. Let's jump to transitions. So there are a lot of bindings and React libraries around animations. In my experience, I work with React Transition Group and then using Greenstock to animate the DOM elements. So the React Transition Group right now, at least the last version, has a transition group component, a CSS transition component, and a more low-level transition component. So let's go again quickly around the API of these 3 components. So let's see that we want to declare a CSS transition. The first thing that we need to do is to wrap our component in a transition group. It's going to handle like the heavy logic around it. And then we're using a Boolean that is going to change over the life cycle of our application, maybe a state, maybe a prop. In this case, I'm calling it is open because it's a pop-up. And the pop-up is also wrapped in a CSS transition component. This component has a class name string and a timeout with the duration of our animation. So what this is going to happen is that every time that is open changes, and let's say it's gone from false to true, then the CSS transition is going to toggle some classes on the pop-up element. And we can use that to achieve common CSS transitions, animations. And the same when it goes to false, then the component is going to get unmounted, and we're going to get another bunch of useful class names. So this is an example. This actually works. It's not fake code. So you see that when the element is entering, we can use fade enter to say, hey, I want to go from opacity 0, and when it's active, I want to go to opacity 1 with this transition. And you can use actually keyframes. This is a CSS transition example. So this component is really useful, to be honest. It's really powerful for the amount of code that you need. It is also useful for rendering multiple elements. and sharing the same transition in each of them. In this case, instead of having a Boolean, we're just mapping some items that also can be from a prop and a state and can change over the time. And we're wrapping the element the same as before, and we can use the same CSS and achieve multiple transitions sharing the same code. This is actually how we handle CSS transitions and animations in our design system at Typeform. So it's pretty straightforward. So the last component is the transition component. The transition component is more low level. I think that actually CSS transition extends from this. It's pretty similar as before. You see that it's mostly the same code. The difference is that now we're more in control of what happens every time that the component gets in the DOM and gets attached. So every time that this happens, we have provided with some hooks, and we can use these hooks, pass some callbacks, and run any animation using JavaScript or any other action that we want to do. So these examples that I show you, really oversimplified, are really great for sharing transitions. You see that we were mapping a lot of elements, and just with a bunch of CSS classes, we're like sharing this animation. But what about custom transitions? What if I have a bunch of elements that are entering the same part of the DOM, but I want different animations on each of them? What about them? This is really a headache in my experience. The project that I was working on in this talk space was using the old APIs from both packages. We're using the previous version of React Router and the previous version of React Transition Group. I really like the new ones. I think that they are in way better shape. I think that when I read the new React Router components are easier to understand. And the same for React Transition Group. It's less obscure. It's more verbal. So I really like them. The thing is that they moved almost at the same time to a new stage. And custom transitions were like way easier before with the old API. So actually, for the talk, I needed to relearn both APIs. So it can be done. I'm going to show you how. So don't worry. It's possible. And once we achieve this, our previous application that we saw on the GIF should be something similar to this. You see that the animation that enters in the home is completely different from the about and the author one. You have a sliding from the bottom of the application, the content, and on the home page, like every line stages in from the left. So we have different content on each view, and we want different animations for each view. So how I do this? So let's go back to our code snippet with all the routes declaration. And we see that we still have the route, the switch, and the browser router around it. So we're going to concentrate only on the switch part, because that's where the magic happens. Right now, this works for us. The problem is that this is a declarative approach, and we need to kind of have more control around what gets rendered every time the location changes. We can right now. We are relying completely on React Router, which is cool because it's a great package. So what we're going to do is a really small change. Look at the code snippet. 3, 2, 1. Boom. It's like simple. Let's go back. So what I'm doing here is basically wrapping everything in a route component. And I'm using a render prop to actually passing the location to the switch component. So this changes nothing. This works exactly the same as before. But the difference is that now every time the location changes, I'm more in control to make some decisions around what is going to happen on the next route. So now we're going to jump into inserting the transition logic on this approach. More code. Let's go line by line over it. We still have the route render prop. And basically what we did here is wrap our switch logic in a transition group and a transition component. So I'm doing this because you can't just wrap the routes in a transition component because you're going to break the React Router logic. So what are we doing? You see that we are getting the location, and we're extracting the path name and the key. Every time that the location changes, React Router is going to provide us with a different unique key for each change. And we're going to pass that on the transition component. So what this is, I don't know if everyone is familiar with keys on React. Can you raise your hand if you know what a key in React is? Oh, OK. I'm not going to explain anything about it. Well, of course I'm going to. So keys, basically, when you change a key in a React component, it forces an unmount and a remount of a component. It doesn't matter if the props are changed or not. This is pretty useful, because every time that the location changes, we pass a new key to the transition. So the transition is going to get unmount and remount. So what that's going to do is it's going to rerun the onEnter hook, and we're going to get the possibility to actually decide which animation we want to run. We see that the onEnter function that we have there, we get as the arguments, we get the node of the view, and the appears, in case this is the first time that the application loads the navigation. And then we are executing an enter function, and you see that we're passing the path name that we're extracting there. So that path name is kind of hard coding part of the approach, but what we're doing is about checking if the location is the home page, or if it's the outer page, or if it's the about page. And based on that, we decide which timeline or animation we're running. So I don't have the time to go over the animation, logic, and part. You can check it after the talk. Reach out to me, I can show you the code. But basically, the enter function should look something similar to this, which is we're receiving the path name, and we see, hey, is this the home page? OK, now give me the home timeline. And if not, give me the default timeline, which is for about and after. And then I just hit timeline play, and that's it. So it's not that complex. Let's move to the next part, which is kicking off transitions on first load, which is kind of like the trickiest part of me working with transitions in React projects. And I'm bringing this up because we were working with a designer around these motions and animations. And he was checking the staging server. And he comes to me and says, hey, you know, the animation hopping is not looking good. I don't like it. I dig into the staging server, and it was like laggy. It was just performance. So we needed to fix that before release. And we were close to release, so we needed to do it now. And my first try, my first hint was to actually move the animation to the next frame. Is anyone familiar with request animation frame here? OK, I was expecting less hands. So request animation frame, what does is that basically we pass a callback, and it's going to execute that callback on the next pane thread of the browser. My assumption was that we were trying to mount the application at the same time that we were trying to run the first animation. So that was kind of like concurrency that we want to avoid. So also like I'm executing the application and mounting it. I'm running the animation after it. So that was the logic behind it. So how you do is that you have some green stock code or some animation code, and you start the timeline being paused. And before playing it, you wrap the playing in a new function, and you pass it to a request animation frame. So just that line is going to do the trick. So if we wrap our timeline play into a request animation frame, we're already moving the animation on the next frame. So pretty simple, right? But it didn't work, of course, because it's web development. So my second try was to actually move to the next frame after the next frame. I know it sounds silly, yeah, because it kind of was. But here's my assumption. So we were trying to do a lot of heavy work, like taking account that maybe the first render that we're doing on the React application is probably the heaviest one. So we want to avoid that stuff. So maybe if I move to the next one, I'm avoiding the frame where the unmounted ends. So I'm trying to push everything a little bit more. So maybe if some render tree already happening, I want to avoid that. So it's pretty straightforward how you do this, because since you want to skip one animation frame, just wrap everything in a new request animation frame, right? So it's super, super smart and super simple. Yeah. I felt smart while writing the code, even when it was just one line. But yeah, it didn't work neither. So my third try was actually try browser hints. So next question, how many people here know the CSS property called will change? OK, yeah, less people. You're not missing out on anything. Sorry. Yeah. So will change by spec, what it says is that this is a CSS property. So you just define, attach that property to an element with a selector. Or in this case, using Grisok, you can use the set function to the node that you're going to animate on your view. And what is going to happen is that the browser is going to prepare some optimizations beforehand. So it's going to get maybe GPU accelerated, and it might bail out if the browser doesn't have enough resources to do it. So the promise that will change, at least to me, this might sound like a rant, maybe it is, but to me will change is a broken promise. I was really excited when I hear about it. We live in a declarative world right now, especially around React and framework applications. And CSS property is imperative, right? So by spec, we are told as developers that we need to wait till the browsers are done with the optimizations on the elements, and then we can animate when we use quick change. The question is, how do I know that the browser is ready, right? How do I know if the browsers actually bail out from applying these optimizations? So there's actually no way, and of course this didn't work at all. This didn't help, and sadly, in my experience, will change never did nothing around complex situations and animations and performance. So my first try was to change the animation method. We're using Greenstock, as I mentioned before, and Greenstock has a bunch of useful APIs methods. You can go from to, stager to, stager from to. There's really good options. So from to is kind of heavy because you need to define both states, and Greenstock needs to do a lot of calculations around them. So what I did was to move all the CSS to the final state of the view and use only from. Code was cleaner, but it didn't work. This was definitely a desperate move. It was based on nothing. So it makes sense that it didn't work. So by this time, my day was ending. I was kind of tired, frustrated. My head wasn't working that well. So this is maybe the first advice that I can give to all of you is when that happens, really don't feel guilty to walk away from the screen and come back with a fresh mind. So I did that. I just went back home, pour a glass of wine and relax and chill. And looks similar to this. I didn't spill that much because the wine was good. So I came back the other day to the office with a fresh mind, and actually, before jumping into the code, I said, hey, why don't we just profile the staging server, right? Let's run an audit. We have great dev tools right now. So let's do an audit and see if we find something. So curious thing is that I did find something. So you see that this is something similar to what I saw that day. You see that we have the animation tagged in the timeline of the dev tool, and you see that there's a blue and a red bar crossing in the middle of the animation while the animation is happening. So these two bars actually represent the event load and DOM content load event of the browser. And my assumption around this is that I don't want this to happen because when DOM content loader has not fired, it's because maybe the DOM tree is already updating. We're injecting some element in the DOM tree, and the browser is still figuring out that. And maybe there's some heavy parsing around a resource. So the thing is that the browser is busy doing something else. So I said, okay, next goal is to move the animation after these events happen. So maybe you're familiar with add event listener. It's a primitive from the browser that has been around for a big amount of years already. So I'm not going to explain it, but assuming that we have a timeline that we need to play, we just wrap our timeline in an add event listener, and when the load happens, we trigger the timeline playing. No, bad idea. No, poop. Why? The problem is that if for some reason we're in a really good situation where the performance is good, the loading times are good, and the load event fires before we declare this callback, this method is never going to run. Never. And we're going to get a blank page. No content to the user. We definitely don't want that. So the issues with this approach is basically a race condition. We somehow need to figure it out how we're going to make sure that whenever the load event happens, we're not skipping it. The other problem, and this is not reusable. The application that I'm trying to use is pretty simple. It has just one animation. But in real heavy animated experiences that I've worked in the past in React, I needed kind of trigger a lot of animations, maybe a banner, maybe a footer, maybe a header, maybe a logo. So I don't want to wrap all my animations in an add event listener and hope that all of them are executed. And the other thing is that we have a lot of scripts like maybe helpers, I don't know, analytics, tracking stuff. and those are async defer scripts. And if we rely on one of those, maybe we're code splitting, and we're waiting for that, and that won't help also with the race condition situation that we have. So we have also a browser primitive that can handle asynchronous. Someone want to guess? Okay, it's promise. Promise is here for this. It's here for asynchronous, right? We don't know when something is going to happen, so we create a promise and we react to that. The thing is that we don't have promises for load events. So how we achieve this is pretty simple. This is an approach that I at least never saw on the wild. This is in production somewhere. But basically, we create a load promise. You can put this on the head of your index HTML. It won't hurt because it's just 2 lines of code. And you create a new promise. You expose it globally so you can reuse it in any part of your bundle. And you pass the resolve as the callback for the load event. So basically, you're going to have a load promise globally available in all your code. And you can just react with it using then. And instead of wrapping in an nav event listener, you just say load promise, then run my animation. So if for some reason the promise got resolved before our bundle, we don't care. Promise is going to work. And if it didn't, well, when the promise gets resolved, our animation is going to run. So you might wonder if this fixed the problem. Ta-da, yeah, it did. Because the animation now happens way after the blue line, which is what we wanted. So yeah, this actually fixed for real the issue on the staging server. So I was really happy. So the next question is, if I think that you should go and run, grab your laptop and do this on all your applications if you're running animations. Quick answer, we say no. Because this worked for me in one specific case, and this was a result from debugging and actually profiling my application. So really what I want all of you to take from this talk is to please profile your applications. We have really great dev tools right now, way before a long year before. So let's use them. Let's make use of them. And if we're trying to modify something because we don't like the performance of something, let's profile. Let's see if we can find something. So to end my talk, a couple of recommendations around running animations in web applications, not only React applications. So this is general, even if you're using Vue, Angular, or even Vanilla.js. So my first take is like when animation is happening, nothing else should be happening. Like animation and performance get really easily hit by anything happening in the application. So if you're parsing something and you've done some heavy calculation, you're updating the DOM, you're injecting a lot of nodes. Just like create a method to wait for it, as I did with the load event, and react after that and run the animation. No animation is better than a crappy animation. This is probably the most important one, because we sometimes, because of design and at least mostly maybe in marketing industries where I work in, I was really pushed to animate everything. So the thing is that I think that the user will prefer to just see the content if you're going to run a really laggy and bad performance animation. So start simplifying it, try to move to a CSS animation, try to do less stuff. And if you see that you still can't get it because your application has a business logic running behind, just remove it and display the content. Like it's a completely fair sacrifice. And this is like important not only on devices like laptops or smartphones, but testing less perfect environments. We were testing this in a staging server that was, of course, less powerful than a production server. And I think this kind of overexposed the performance problems and issues on the first transition. So let's test in less capable devices. Not all of our users have like the biggest network speed, like the best laptop and the best phone. And last time I'm going to mention this, let's profile your applications, please. So a couple of resources. The application that you saw in the GIFs exists. It's real. It's in GitHub. It's here, technically in one of the servers. So you can check it out. Like fork it, clone it, download it, run it locally. Actually, this promise-based initialization that I mentioned to you, I actually wrote about that like 2 years ago, way before having this issue. It was kind of weird that I already solved this for myself. So yeah. So you can check that article out and see more reasoning around that. The React Router documentation around transitions is pretty good. When I was trying to relearn the new API, it was really helpful. So check that out if you're more interested into this. And React Transition Group also has documentation. Not a fan, honestly, but it's complete. It has like all the options, all the props, and all the hooks. So if you have any doubts around this and around this approach or around building this kind of experiences, just reach out to me on the breaks. I'm available, and thanks for having me. It was a pleasure.